The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
By the way, you getting delayed was not my fault at all. It was only 20 minutes.
100% was your fault.
No, it wasn't. I don't know how you guys keep blaming that shit on me.
Yeah, it was your fault. I mean, there's nobody else's fault it was.
How long were you delayed?
30 minutes.
See, wasn't it nothing? That's not getting Wetzel. Wetzel is anything over an hour. So
yeah, no, it's definitely your fault.
It's still not my fault. Good morning, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. God, my voice is getting worse every freaking week.
It's because you're old.
No, because I keep talking every week. Jesus. Because I keep talking every week.
Because you're old.
Shut up. No, it's not. How was your week? You didn't work. What'd you do?
I was on vacation while everything was burning back home because it was 100 degrees.
Oh, my God. How did that work?
So not good. My phone was exploding the entire time. And then we were in South Carolina, and it was like 100 degrees every day with 90% humidity. So it was just miserable. None of the kids wanted to be outside and doing anything. It was just miserably hot.
Everyone wanted to stay on their iPads and shit and do absolutely nothing.
Yes. So it was brutal.
This week I was home-ish. I was home, but I was doing training. I was doing training on RDM and cascade CO2. My goodness. Some of the stuff is, I don't know. We're gonna end up just talking about cascade because apparently people they don't really get the concept of how this stuff goes. And so I figured why not just talk about it again. And I know we did before, but I don't know, just to solidify some of the issues. And some of the issues that I did find, it's on HFC rags, regular standard HFC rags, they're not as critical to keep the suction as straight. Yeah, the EPRs will react a little bit differently, but when it's paired with where it's HFCs being the primary and the cascade secondary is CO2, it is really important. I'm going to see if I can send these pictures to myself really quickly so I can actually show.
This is the lame CO2.
The Powerade. The Powerade, I think we referred to it as.
It's nothing but problem CO2. It's not. I don't think it's nothing but problems. Nothing but problems. You're better off going transcritical.
Oh, stop it. Oh, you're so whatever. Anyway,
it's like buying like the knockoff food.
As far as a lot of the problems that happen with cascade CO2, it's predominantly anything that's on the primary side. If the HFC side is running awesome, then everything else will run amazingly.
The HFC side's never running awesome. It's always got some massively oversized compressor on it for the lead.
Not all the time. Not all the time.
Or it's got digital unloading on it for the lead, and it just EVs just hate themselves.
And that's the whole thing. So all the case controllers, especially if the case controllers that are run the primary side downstairs do not have EPRs. There's a lot of cycling, and it exacerbates it with having a really bad suction control downstairs or upstairs. I'm sorry, up on the roof at the rack, where your suction pressure, if it's over the, oh my God, I can't talk. If it's all over the place, the case controllers have no idea what to do. Like it might be, at one point, it might be 5 degrees of superheat, and then it might be 10, and then it might be 15, it might be 15, 20. Like, so the valves are constantly like overreacting based off of that suction. So that's a lot of times what causes a lot of the issues.
If you're going to do cascade, the lead needs a VFD, and then every other compressor needs 1 to 2 unloaders. It needs a ton of staging to be able to manage and not hunt like crazy. And to be honest, it almost needs 2 lead VFDs. It needs a smaller lead VFD and a larger lead VFD in order to work properly.
So this one on the HFC side, it did not have a VFD. It had a Vari-Step. They call it Vari-Step. Yeah. No, it works good. I think it works good.
Was it the older Vari-Step or was it the newer like CMRCs?
No,
CMRCs work great.
It was the Siemens.
Yeah, that one doesn't respond fast enough. The CMRCs are great, and they're so quick.
But so I didn't really have access to change anything in the program. So one of the things that I did notice, you are right, it doesn't react, it's really how fast the signal is being sent to it, right? So if they are not sending the signal to be very responsive based off of what the deadband is on the suction, it's the same thing if you have a VFD operating too fast or too slow, where you're sending that signal out that way. So here, I'm going to share a picture real quick.
Yeah, I'm not a fan of the old Bitzer modules now that the CMRCs are out. I don't even think they should sell them anymore. The CMRCs is such a better product.
This was an older rack. This is from 2000, in the teens, I think. It was it was like 19 or something, 2019 or something like that. But you can see the suction control was meow, and then it was
nice fake graph. You graph out an hour before you fixed it.
If you son of a bitch, I did graph it over. You're an asshole.
Let's see that 2-day graph.
It's a 24-hour period.
Cheating motherfucker.
All right. All right. I'm going to see if I can get access to it real quick while we're doing
no, it's fine.
Bastard. No, but it did look like shit. You're such an asshole. Greg's going to listen to this. Yeah, that graph looks great before. That's the only reason why the other part looks. But yeah, so this is the suction control on the other side. So apparently in the program, it thought it was a VFD compressor. So once we told it wasn't a VFD, because it kept trying to put it in bypass, and so that 6-cylinder that had the Vari-Step on it would come on for a couple seconds and they turn off. And at first we thought it was a safety, and then I went back, it's actually coming from the control. So I had to call the people that watch over the system, and I was like, hey, what do I do? So he reset it to be a stepped compressor, a Vari-Step, and then he said that I had to reset the actual main controller. So on RDM, they have the 650 Super Pack that controls the rack. So what I had to do is I had to reset. That's why we have a gap right here, right before this whole thing happened. But as you can see, it's a lot tighter than what it is. Now, unfortunately, the suction is running all the way down to, let's see, average seems to be about, I don't know, probably 18 or 16 degrees saturation, maybe a little bit lower, depending if you're doing dew point or midpoint, right? But what was happening is a lot of the cases, all the cases downstairs don't have any EPRs. So what happens is you're still going to have these spikes because the cases are consistently turning off and on. So if you had an EPR on the whole branch, on the whole loop, where you can keep the pressure up, all these cases wouldn't satisfy. At these particular stores, a lot of times, I'll do graphing on the EEVs, and you'll see 3/4 of the EEVs off at any given point in time.
It's every cascade rack because nobody wants to put the EPRs in.
Yeah, and then they're like, you don't have to waste energy. Yeah, but it wastes more energy with the cycling and everything like that. So as you can see on this graph, over 24 hours, you jackhole, you can see that the suction pressure did get better. You're a dick.
I made this look better. Don't ignore what it looks like from 11 to the day before.
You're a dick, because now I'm gonna try to get access to it
when all the load comes on.
Anyway, So you can see that after I got it running steadier, you son of a bitch, you can then see what happened to the discharge pressure. Now you see this is the discharge pressure on the actual CO2 side, on basically the receiver pressure / discharge pressure. The only reason why this still doesn't look as great as what it probably should is because the VFD compressor on the CO2 was not working. So a lot of times it would have both compressors running, and instead of just varying that VFD for the CO2, it would just, if the suction got too low, it would just knock it off.
Did Greg work on that one too?
No, Greg didn't work on this one. That was actually the VFD that I showed you in that picture. And no, Greg, you didn't work on that one.
Yeah, it would be a lot more steady. Like with the CO2 load, like it is super important to keep the load stable on the CO2 side, meaning you don't want cases shutting on and off, and you also don't want any cycling on the compressors. Like you try to maintain as little cycling as possible. So like that VFD compressor being down probably is making that rack want to just hang itself, because it's just hitting and stopping, and it's making spikes on the plate and frame, or the braze plate, sorry. And people get all salty about that.
They do. I don't know why. The other ones have bolts. These ones are all soldered together. I'm like,
okay, it's
all right, just the heat exchangers.
The spikes on that and pressure, it does not handle it well. It does not come down quickly. So that's why keeping this thing steady is super important. And that's why everybody misses the HFC side. They're like, oh, it's at suction pressure. That's great. It has no mass flow because it has no case flow. The chiller is the only thing. So then when the chiller loses a little bit of load and you get some low temp load come back, like the medium temp trails behind it, and then you get these random high vessel pressure trips, and you get these random spikes in discharge pressure trips, and it's just not good. Staging between the stages, like between the inner stage, it gets all jacked up. Like it just takes a little bit for that pressure to come back down after it starts pulling that heat out from the braze plate heat exchangers. But 100%, those braze plate heat exchangers should have EPRs on them too.
Yeah, this one did not, because usually now, because I think this was one of the first ones they did, but now, like, you typically like to put EPRs on the heat exchangers. They'll do 16 degrees saturated. They'll maintain 18 saturated on the braze plate, and then essentially you'll get your 25 degree CO2 or 440 PSI for your set point for your cases. Or I'm sorry, for the liquid.
Non-stepping EPRs, they should be fixed Parker A8s.
No, 100%.
Like
100%.
If you start trying to put EVs and EPRs together, it never ends well, especially when you got two different PID loops going and they're rapidly changing. Like a mechanical EPR is going to maintain this so much better. Digital compressors and EEVs do not go together.
So I'm going to add this back real quick.
Oh, is it the graph where you...
No, it's not the graph that you're an ass. You're an ass.
Oh, 113 degrees. Gross.
So yeah, that's all right. So this wasn't this heat. This wasn't this particular rack. This one was actually set for 95. So your discharge temperature on your CO2 compressors can be anywhere from 150 degrees down to maybe on a lower day you might get about 130, 127. And those heat exchangers can't take. They don't want to risk fracturing them because you have the cold liquid entering at 18 degrees. And you have hot discharge going in. So what they want to try to do is before the actual hot gas enters the heat exchangers, they'll cool it down to whatever the rack specifies. On this particular one, they were doing about 113. And some of them you'll see down all the way down to 95. They usually do that with a desuperheating valve. It's usually a three-way MTAW, basically a Sportland three-way valve. So then that way they can take some of that hot gas, put it through there, and then it mixes with the other vapor that's passing through. And then they'll have a temperature sensor right before the heat exchangers that basically measures that temperature to try to maintain that. So once we get down to there, so this is what I wanted to show you. On these heat exchangers right here, you have two braze plate heat exchangers here. The saturation is at 18 degrees. It looks like I tried to understand this and I was like, it looks like they're trying to maintain, if you look at this, about 5 degrees of superheat because they're telling you about 23 degrees out. And then you can see the CO2 entering is 113 in with 25 degrees CO2 out, which converts to 440 PSI. So that's what you should get on your receiver pressure. That is only if you're maintaining a steady suction pressure, which, back to your point, Kevin, where you're talking about putting the EPRs in there, but also a steady superheat. If you do not have a steady superheat for whatever reason, oversized valve, rivering in the sight glass where you're not getting a full column, any of those reasons could be the reasons why it ends up eating shit, and then you're having the intermittent high vessel pressures.
Yeah, the rivering in the sight glass is a huge problem, and that comes back down to a load issue. When there's no mass flow on the medium temp because everything's shut off, there's a load issue. Like, I've been floating up a lot of these. I've been raising up the suction SSTs to run like a plus 20, plus 22, because the problem is if you have a store that uses electronic EPRs on the medium temp cases, you're even more hosed because now all those are shutting down and they're all like 5%, 10% closed. That ends up hosing you just as bad as the EEVs not feeding, because now you still have no mass flow. And what you end up having to do is raise the suction pressure up. You need to get those EPRs to open up. Yeah, the CO2 may take a little hit, like a tiny hit, a couple PSI, raising that suction pressure up, but it's going to help you in the long run when everything's stable and steady.
I agree with that. Let me just bring this other one back up now. So this is basically the HFC side. On this one, we had lovely 513. I know, Kevin, you love this gas. It's awesome.
Worst.
Yeah, they've 513 really is exactly 134A with a little bit of that. What's that?
134A wasn't a good gas either.
Yeah, I know. So this one has 134A in it, 44%, and then a little bit of that R1234YF. So this is how they're running this rack. So basically they're doing a 16-degree header, saturated, and I just have, you'll expect about 38 to 58 degrees, giving you some probably 20 to 40 degrees of superheat, then going out about anywhere from 120 to 200, and then the pressure range could go from here to here depending on your ambient. And then coming back to the receiver, if there's no subcooler, you'll get anywhere from 77 to 167 PSI. And like I said, 70 to 115, and you'll get anywhere from 65 to about 110 degrees, depending on how high your ambient is at that point.
You need to have massive valves in order to float 134 and 513 racks.
What do you mean?
To float the head. Because they have such a low pressure drop across the valve. So the valves end up being massive.
That's why a lot of the times they'll forego the savings that you get with floating the head down. And they're like, fuck it, we'll keep the head pressure a little bit higher.
Today's episode is sponsored by the RefRuShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
It doesn't really work that great on 513 and 134. It struggles.
It does that too.
You need to have massive valves in order to not have flash gas across the valve.
5 to 113.
What are you doing?
Nothing. Don't worry about it. What'd you think I was doing?
The graph that's still bothering you?
Mother of Christ, no, I'm not doing that. I was fixing some numbers, you jackhole. So this is a combination of the CO2 and 513 side. You can see the braze plate heat exchangers right here. Basically, you can see here I'm doing the saturation temperature and pressure that we're trying to maintain what kind of superheat they typically see on these things. And then you get about a 7-degree TD, which gives us the 25-degree SST CO2, but it also gives us, because it is basically a saturated mix, you'll get about 25, 26 degrees leaving, and anywhere from about 435 up to 450 PSIG. But before it actually goes in there, this is that desuperheater I was talking about. They do the desuperheater 2 different ways. Sometimes they utilize a separate pass of a condenser, like a BAC adiabatic, or sometimes what they'll do is they'll have a separate coil altogether, just a fan and coil going in together. Sometimes they'll have one that looks almost like a remote ice machine, and then sometimes they'll have one like Bill Phoenix is one of the first couple renditions. They had the one where there was just vertical like this on the side there of the rack, and it just had a fan. It looked like an exhaust fan, really, but essentially it was acting as a desuperheater.
Those were tanking the racks when they first came out, when they had no bypass on them.
Oh, I know. I spent hours on it.
Braze plates can't handle liquid going through them. They're not large enough to flow liquid through the holes.
So let's go through this real quick. Like I was saying before, you'll get about 120, 155 coming out the discharge. And then coming out of the desuperheater, whatever this temperature sensor controller is set for, like I said, it could be 113. On some racks, could be 95. And then that's where that vapor goes into this heat exchanger and then comes out a liquid. Because these heat exchangers are huge. They're made for latent heat loads, right? So if you're not putting vapor in there, these valves are essentially now too freaking big. And then they will hunt and usually end up flooding out the compressor. So coming out here from the bottom on the TS7, TS9, and TS11 here, you get about 25 degrees CO2, which is, it should be the same range of whatever the head pressure is running at that point. So back to what you were saying, like I said, these heat exchangers are massive because they need to be able to convert that vapor into a liquid. And sometimes, like you had said, if this valve sticks in the wintertime, it's not going to end well for the HFC compressors, because a lot of times what will happen is if this temperature of the CO2 gets fairly close where it starts condensing and actually turning into a liquid, you'll see it like this TS6 sensor, where it's typically the 95 to 113. If you start to see this delve down to 38 degrees, 40 degrees, or anything close to that, now you're basically condensing that refrigerant into the CO2 side into a liquid. The liquid goes in the heat exchanger, and then the valves, I don't know what I'm supposed to do with this. I'm not sized for that. It's way too big. So you'll see it like the valve open up a little bit and then close, and open up a little bit and close. And
that it causes high head pressure issues because it can't flow through the braze plate efficient enough as a liquid.
Is it that? Hold on. Is it that, or is it?
I think me and you thought it was that for a while. I know the valve just goes to shit while it's going on, but it doesn't seem like it gets, like, temperature wise, it's fine, but pressure wise, it's high.
I know, but what I'm thinking is that if there's no vapor in this line to condense, let me think about that for a sec. If there's no vapor in that line to condense, that whole receiver is going to be just nothing but liquid. No, it's just, these have no load. So it can't bring that. Because these heat exchangers need vapor in order to bring that pressure down. And that's why every single auxiliary condensing unit is typically towards the top on the flash tanks for transcritical, right? Because you can't just run that liquid and get that liquid pressure down. We're basically just taking that vapor off the top. But yeah, no, that would also make sense.
You don't have to flow through it when it's a liquid in those braze plate heat exchangers in order to properly bring the pressure down. So and you don't even need to have the fan stuck on. If the three-way valve's stuck, it's enough sometimes when it's pretty cold out to drop it down enough where it condenses and you start having problems.
No, I remember that we had the one that on that hill rack out towards Fort Worth. All it would need was just wind going across without the bypass. That vapor would start to condense into a liquid, and then forget it. The rack just went to shit. The compressors ended up flooding out. And at first I thought I had it licked with tuning because it had those awesome SMS controllers on there first.
Oh.
Yeah. Where you need the computer and the dongle in order to see it. And the only thing you have to tell what's wrong are the lights. You can't tell what the actual temperature sensor is unless you actually have that little dongle and you have the software that
doesn't work on any computer.
It does work on the older ones, but yeah. So I changed them all out to Sporlan because Sporlan actually, I'm pretty sure, made the SMS for Hill because it used the same exact pressure transducer, same exact temperature sensors. So like doing the conversion to the Sporlan superheat controller was easy as hell.
Yeah, you just need that. And then new temp sensors because you don't know if they're bad or good.
Correct. So on the other one, it didn't have the three-way valve. It basically just ran it through. But the problem is that even when it got down, and yes, it does get down to 20 degrees here. When it got down to 20 degrees or 10 degrees here in Texas, with the wind, because there's no mountains to stop anything, it would just sail right through the heat exchanger. So we inevitably on that particular rack had to put a three-way valve, like essentially almost like a split valve. So if it got down to a certain temp ambient outside, we basically bypass it.
Yeah, I mean, Cascade is pretty simple with that, but if you don't have good suction control and you don't have good superheat control, you're done. It's not going to work.
Or you just fake the graphs like I did.
Yeah, or you just show like graphs where everything loads up at 11 o'clock when the store opens up. And
that's not what it was, you fucking jackal.
Okay, I've seen enough fictitious graphs in my day to I'm just calling out how I see it.
Apparently now anything we say we need proof. So
yeah, because
fictitious sources.
You have fictitious sources, fictitious graphs. You're just over here making everything Brett does look good. I fixed. Look at this. Look real bad where I photoshopped the time in. Let me move this time over. This was midnight when there's no load. Yeah, honestly, Cascade is okay as long as you keep the primary side going. I really wish they would up the relief a little bit on them, though. I know it comes down to compressors.
And the piping.
Yeah.
That and the piping, because the compressors, the subcritical compressors, just ask one of the other kids what happens when you put the wrong relief on that wrong compressor. It's now gasket day.
Yeah, it becomes a problem. That's where we're at with that. Honestly, I would much rather just see straight transcritical. I think transcriticals come so far, and it's gotten so much better. Like the BAC towers, the last two I started up the BAC towers, like I was pretty impressed with the heat transfer on those, and they did pretty damn good. Like I seen one the other day of a BAC in Colorado where it was dropping the entering air down like 25, 30 degrees because it's so dry out there.
Yeah. Yeah, but I really want to see more. Like instead of having like you can have the Modbus control and that's great, but like being able to actually
control the fans.
Yeah, like the on and off of the fans. And
so they're all dropping the ball on this because none of them are letting us control the fans where we could shed fans. I don't need 6 fans coming on at once. I need 1 fan.
If it's a place where the temperature is the same temperature all year round, great. Awesome, because then it's sized for that point. But that's this whole reason why. Remember when there was that big push for energy optimization, right? And everyone was throwing VFDs at condensers, even if the condenser was 90 years old. They were like, yeah, that'll make it more efficient. We'll just throw on another one. But then we ended up evolving with it and essentially going from not just VFD control, VFD signal control, but we did a combined method of single speed and VFD. So like basically if the pressure started delving down too low, then we would start staging off the fans as well.
Yeah, and in wintertime, you get a much better control off of 1 fan running on the VFD at 50 to 60 hertz than 6 fans running on 50 to 60 hertz.
100%. And the Gunnar has it, but I guess BAC, because I was having this conversation with the guy. I'm like, how comes you don't? He's like, because we don't have guards in between. They don't have like sets in between each.
Who cares?
Yeah, and that's what I guess the fear is that you would essentially start pulling air in instead of across the gas cooler or across the condenser, whatever it's being used for. You're pulling it then through the fan. You know what I mean? So you're not getting optimum airflow, but then
it kicks on another fan.
Then put dividers between it.
Yeah, I mean that is a huge issue with those gas coolers and condensers. Like on the BACs, like they would be so much more efficient if they put through a cheap, shitty sheet metal baffle in there.
Well, they couldn't do sheet metal because how humid that air is. It would.
Oh yeah, you throw a stainless steel baffle in there, like it would literally make those gas coolers 10 times more efficient.
Because then you could actually have better control, and you could actually stage it off. Shit, you'd figure out how it would run. You could stage it off via ambient. You know what I mean?
Yeah.
I know that when the ambient gets down to this, I don't need this other fan. You know what I mean?
That until that happens, we're still going to be fighting this load issue, especially the CO2 racks. We're still going to be fighting this poor control. 90% of the poor control issues start at the gas cooler. And unfortunately, when you have no control over the fans besides sending it a 0 to 10 volt signal, there's not much you can do to fix it. Like that I start my tuning every time at the gas cooler, because the gas cooler is what causes 90% of the control issues. It starts there and it trickles down to the compressors until the gas cooler manufacturers, take this seriously and figure out a way to shut these fans down one by one and in a proper way. We're never going to get the control out of these racks that we're having. And until the end user forces the OEMs to do it, it's never going to happen.
No, it's like trying to run, like I said, trying to run a large condenser, like where you're just ramping everything up and ramping everything down. There's a limit, especially if it gets really super cold out. Like I said, that's why we started with running every single fan single speed, variable speed, and then we added that's why in the E2 there's SS
VS and VSS combined.
Yeah, that one there. So it basically combines the methods of shutting off the fans, but also ramping up and down the VFD. And so when it ramps up, typically, correct me if I'm wrong, but it ramps up. It might start with one set of condenser fan motors and then ramp up. And then if it needs another set of condenser fan motors, it'll bringing them on.
It'll keep staging them. And then as the PID starts dropping back, it starts dropping back fan motors and then speed and then fan motors, then speed.
But it would bring a whole bunch better control to what we're trying to accomplish. Back to the Cascade one last time, with making sure that your pressure transducers are accurate is imperative. You'll see here, because your suction is running at the 16 and all the rest of your cases are running probably 24, 26 or 28 degrees saturated. If you're running even lower than that, you're gonna stage off a lot of your cases. So this is I hate how they do these graphs, but you can see right? There's a lot of stuff look how many freaking valves. So you see all the valves that I have selected here. So this is the cycling off and on over I'm not sure how long this period was, from 5 o'clock in the afternoon till about 4 o'clock. So it's probably 4 to 4. So it's a 24-hour period.
Put 17 things on here so nobody could see
the only reason why I did it, not for the visual graph, but then you can actually see how many of the expansion valves are actually slammed down to nothing.
Yeah, it's bad.
And so all these other ones, I'm willing to bet I didn't do investigation because I was trying to get this training finished. Because every time I make training where I get access to a controller and I'm like, oh yeah, then I'm like,
no, you're like squirrel.
All of a sudden, I'm going down a rabbit hole. I'm like, what? Why is this one running at 65%? Why is this one running? Oh, the sensors are swapped. Why is that one? And then I get sidetracked for 3 hours, and I'm like, where did the time go? And then I'm like, shit, I'm still not done with doing this training. But yeah, some of these other ones might be that there's problems with the sensors or problems with the cases or whatever. But my point being that when the suction is really low comparative to what the cases need to be, you're going to have a lot of cases essentially shut off. And when you do that, it causes a lot more cycling on the rack. But on top of that, we've seen with a whole bunch of these different gases, 448, 449, 513, if that liquid line, like that conversation we had with Joe Sig, if that liquid line, it doesn't have the correct velocity going through it because we basically have shut off 7/8 of the damn cases, then you get that stupid rivering. You can have 70% in the damn receiver and you'll still get that rivering effect.
Yeah, it's a problem. Is all the new racks have been having it because they've sized liquid lines wrong and sized lines wrong. And all these brand new racks, the last 4 racks have started up have rivering side glasses.
They size them up for They probably size them up for 100% capacity, right?
Yeah, which it never has.
I know, but if they're probably running at like 20 or 30% because of all the expansion valves that are basically shut down. But once again, this is another reason to push EPRs on systems so you have more steady flow. We've done it before with just regular conventional HFC racks after a conversion. You're still running a low saturated to maintain, let's just say, a meat box. Unfortunately, like that is going to be at plus 18, which means the rack has to run at least plus 16. And so all the rest of it,
plus 18. Stop at this two degrees less.
That's usually what it says. I'm going off what it says on the schedule. Your schedule is different than real life. I get it. But it depends on how the piping was designed.
Throw the schedule in the garbage. You just change the gas.
Shut up. Anyway, every single rack, if you look at every single rack's schedule, it's usually set about 2 degrees lower than what the lowest SST is on that rack. Is it not?
Because they're just doing copy paste.
I don't look at the schedule. I don't do that.
I'm trying to make it run better. Copy paste. That's all they're doing.
Anyway, the point that I'm trying to make is the fact that if we're running way lower, you're going to have a lot of stuff shut off. So if that suction pressure transducer is off, that could be another reason why your cases are eating shit as well.
Or somebody offset it.
I couldn't help that my analog gauge was off by 2 pounds. And
God. There's that one commissioning company out there that every transducer is off by 2 pounds. I just want to, every time I see that, I just want to strangle a guy.
I saw that on a rack. We went through the pressure transducers when I was out.
Yeah, everyone's off by 2 pounds, buddy. No, your gauge is off by 2 pounds. You need to retire.
It must have gotten dropped because that was off by 3.
Yeah, it's one commissioning company out there, and it's the same thing every single time.
Stop it!
I want to buy the guy a digital gauge so bad,
Just send it to him in the mail.
Like, it's not every transducer is off by 2 pounds. There's something else wrong, like your gauge doesn't work, or like your 1972 Yellow Jacket mechanical gauge that you've had since you got in the trade doesn't function properly anymore. That triggers me. It's the same company, and then the people are like, customers are just like, oh, they're all off by 2 pounds. They're not. It's impossible.
I can't even make anything up. I'm like, maybe they used the wrong wire.
Maybe it makes me so mad.
Maybe I got something. Maybe the board that's powering all the pressure transducers has a little bit of, it's not getting the full 24 volt. Maybe it's only getting 22, so it's offsetting the pressure a little bit.
So fix the board, not offset all the transducers. It's always these old boomers too.
Stop it. You're basically a boomer. You know that.
I'm not.
You definitely are. In spirit, you're a fucking boomer. Just not in age.
I believe in new things.
Yeah, I know.
Guys, that was transcritical or cascade. The transcritical wannabe CO2.
Go back to bed.
Yeah. I gotta go run calls.
All right, guys, have a good night. We'll talk to you guys later.
Doing absolutely just wretched. And sorry, black. Bye.